If you take A Math and if you're in Sec 4, differentiation is one of the first topics that you will learn and have to master. And this is one of the first confusing things about differentiation, which is increasing and decreasing function. And this is really the bedrock of your whole differentiation chapter, because differentiation is really the biggest chapter in your whole A Math. And this application is one that will come out multiple times across all different kind of functions. So how do we even tackle this, and how do we even understand what is going on? Before we even ask ourselves, when is this quadratic function increasing? Let's first draw out and sketch how to visualize this graph. So over here, this is my y-plane, so this is y, this is x, and I can tell that I have two x-intercepts. One is at -3, one is at -1, and then this is the y-intercept is 3, right? And in the middle, this is where it's going to be -2. So you can see that for this graph over here, we can split it into two portions. The first portion is actually the decreasing portion, so this is number 1, and then the increasing portion is actually over here, number 2, where it's going upwards. The graph is split into these two portions, and over here at the -2 over here, this is where the graph is actually flat, right? So over here is neither increasing nor decreasing, and this is what we call a stationary point, because the gradient is not changing, right? The gradient is 0 at that point, but that's a video for the future. So how do we find out when the graph is actually increasing? You can see that the graph is actually increasing in the number 2 portion, and this is the first key concept that you need to remember. When a graph is increasing, or for the portion of the graph that is increasing, the dy dx will always be bigger than 0. And why is that the case? Because dy dx, as what you have already learned, represents the gradient. So when the graph is increasing, the gradient has to be pointing upwards, because that is the only way that the graph can be increasing, right? If the gradient is pointing downwards, then the graph definitely must be decreasing. So for a graph to be always increasing, the gradient has to be pointing up, and that's why we say that the dy dx must be positive for the portion of the graph that is increasing. So with that in mind, right, how do we tackle this question? It's as simple as first finding the dy dx, and in this case, the dy dx will be 2x plus 4, right? That is what you learn from your laws of differentiation. And we know that the dy dx has to be positive, this equation has to be positive, when the graph is increasing. So from here onwards, we just need to solve this linear inequality to find out what are the range of values of x for which the graph is increasing. So 2x plus 4 is bigger than 0, 2x is bigger than -4, x is bigger than -2. And as you can see over here, as long as x is bigger than -2, which can be reflected on this graph over here, -2 onwards, the graph is actually always increasing. And this is how we tackle increasing, decreasing functions in differentiation. Now that you understand the basic concept, it's time to go and practice exam-specific questions that test you on this concept, so you make sure you get the full mark. And I filmed many videos for many different types of increasing and decreasing function questions in my library of A1 Math Academy, where you can get access to and also get access to our 24/7 turnaround premium marking service for all of the papers that we have set inside that portal. So if you want more practice on increasing and decreasing functions, just WhatsApp this number and I'll send you an info kit to show you more about what the library actually contains, as well as a demo link to show you how the subscription actually looks like once you get it. With that said, WhatsApp this number and I'll send you the details there.